Did Central Africans discover prime numbers 20,000 years before the ancient Greeks? The short lecture outlined the contributions of the Stone Age mathematicians of Ishango in Central Africa in 20,000 BC in what is now Democratic Republic of Congo, showing that they had discovered prime numbers before the ancient Greek mathematician Eratosthenes in 300 BC. Africans in the Congo region were doing mathematics and discovering prime numbers, base 10, base 6, and modular numbers in the Stone Age, 20,000 BC, as documented in the world's first known mathematical document and sieve for the small primes, the Ishango Bone. The bone is said to be 10 centimeters long and the bone of a baboon, with markings made by stone tools crafted by the Stone Age people of Ishango in Central Africa. In 1959, the bone was discovered by Dr. de Heinzelin de Brohard in the remaining ash from a bygone volcanic eruption. Then, in 2020, the Society of African Earth Scientists published a paper explaining all 3 columns of the markings and every one of the 168 tallies, claiming the markings exactly model a mathematical sieve for the small prime numbers. What is a mathematical sieve? Well, a mathematical sieve or a prime sieve is simply an algorithm for picking prime numbers out of the procession of natural numbers. Let's think of this as a simple kitchen sieve, or the sieve that you might use to strain your tea when the teapot is full of tea leaves. Let's think of the residue that is caught by the sieve as being composite numbers. Therefore, in this case, the composite numbers represent the tea leaves which are caught and retained in the sieve, while the tea that flows through the sieve represents the prime numbers. So, if we look at our diagram, we can see that all the numbers 1 to 10 are put into the sieve, but only the prime numbers are strained out of the sieve. We conclude this sojourn on the Ishango Bone by recognizing 3 important observations that show us that the tally marks are not random, but are a mathematical document made by people of ingenious intelligence equal to our own as modern computer-age humans, but with less tools like computers or handheld calculators, etc. We had assumed that Stone Age people were too backward because they are primitive. So consequentially, we could never really understand their markings because we assumed they must represent childlike number games or counting. Certainly not considered was the possibility that the Ishango Bone was an effort to discover prime numbers. The first observation is that we notice the Ishango Bone is written in a convention similar to the hieroglyphics convention of the ancient Egyptians. So adopting a convention of reading similar to later Egyptian stroke Kemetic hieroglyphics of top to bottom and right to left shows that the controversial sequence of prime numbers is not merely 11, 13, 17 and 19, but actually starts from 5 to go to 7, then 11, then 13, then 17 and 19. So the convention shows us that actually there are 6 prime numbers illustrated in sequence. The second observation we note is that the Ishango Bone represents a 3-column accounting system which is unified by a common factor of 12. And this, we surmise, is to ensure the integrity of mathematical information was not lost or compromised. Lastly, we notice that in the right-hand column of the Ishango Bone, the range of the mathematical sieve is represented. We see the adoption of a modular mathematical symmetry with opposite signs, 10 plus or minus 1, 20 plus or minus 1 in one column as a way of aesthetically representing the range of the Ishango mathematical sieve. Again, this style of symmetrical, economic, aesthetic representation of information reminds us of the later ancient Egyptian hieroglyphic convention. The algorithm of the Ishango Sieve itself uses a method of doubling and adding to perform more complex operations similar to later Egyptian mathematics used to multiply and divide large numbers.